this conversation was, oh my gosh, how long has Donald Trump been our president? A year and a half? Okay. So a couple years ago, prior to the elections, and then especially once the elections happened, this would have been a very, current event sort of situation, because all the polls said that Hillary was going to win, and they were predicting that based on samples and going out and asking random people. So everyone was very surprised when all of this happened. But anytime you're taking a poll and you're only taking a sample, there's a margin of error. That's not definitely going to be what the result is. So this first exercise just gives a hypothetical. A recent poll found that 36% of all respondents would vote for candidate A. The poll reported a margin of error of 4%. So what that means is that their best guess is 36%, but based on this margin of error calculation, it could be give or take 4 percentage points from that. So it could be as low as, so it's 36% plus or minus the 4% margin of error. So as high as 40% of people may truly be voting for candidate A, or as low as 32% could be voting for candidate A. And that's the 2 standard deviations away. Okay? So we're 95% certain that the actual number of people voting for candidate A will be somewhere between those 2 numbers. And that's all margin of error is. So it kind of feels like we've already done it in a way. So in this next sentence, I just kind of further define the 95% margin of error. It's the range of numbers between which a sample is likely to fall 95% of the time when taken from a population about which we know the mean and the standard deviation. So really that first phrase, it's the range between which a sample is likely to fall 95% of the time. Okay? Or we would use it like we would say we are 95% confident that the number of people voting for candidate A would be somewhere between 32% and 40%. And then in exercise 2 here, I'm just pointing out what I've already said. In any normal distribution, how much of the data falls within 2 standard deviations of the mean? That's our 95% number that from kind of day 1 we've had to memorize. So really just pointing out the connection between that and margin of error. So in exercise 3, we have a sample survey. 50 people randomly sampled about their favorite soda. 38% of them listed soda A as their favorite, and the standard deviation of the sample proportions was 0.069. Now that sample proportion is given as a decimal. So as a percentage, that's 6.9%. That's 1 standard deviation. So the margin of error would be double that. 2 times 6.9%. 13.8% is the margin of error. And then from there, the acceptable range that we would be predicting would be the 38% that they actually got in their sample, plus or minus 13.8%. So that could be 38 plus 13.8, as high as 51.8% could favor soda A, or as low as 24.2%. That's a big range. And that's because that's a fairly big standard deviation. So if you double that, and you're going essentially 14 percentage points in either direction, there's a 28%-ish range between those, which is fairly large. Any questions on that? Write this down. Take your mean plus or minus 2 times your standard deviation. Or it could be, this one wasn't technically a mean, this was your proportion. Plus or minus 2 times your standard deviations. And these are both, whether it's your sample mean or your sample proportion. The appropriate window is plus or minus 2 standard deviations away. Exercise 4, different poll, different number of candidates or people being surveyed, 500 this time. Candidate A led candidate B by 46% to 39%. The standard deviations, though, are what percent, Connor? What percent would that be? 2.2%. So for candidate A, who led with a 46% proportion voting for him, that would be 46% plus or minus 2 times the 2.2. So that's 46% plus or minus 4.4. So 46 plus 4.4 could be as high as 50.4% or as low as 41.6%. Candidate B, on the other hand, was a 39% proportion voting for him, plus or minus the same 4.4. That's 2 times our standard deviation. So the reality is that person could have as much as 43.4% of the vote, or as low as 34.6%. And this could be conceivably what happened with Hillary Clinton and Donald Trump, is that Hillary Clinton the whole time was candidate A, appeared to be higher. But with the margin of error, if she scores on her low end and the other candidate scores on his high end, well, then you could have kind of an upset and a surprise, which is what happened. So could candidate B actually win? Yes. Could they tie? Yes. Right? There's an overlap with those. If you looked at a number line, let's do 30, 40, 50. Candidate A is anywhere from 41% to 50.4. Candidate B is anywhere from 43% down to 34. So anywhere in here, and you'd have an upset or a tie. Any questions on that? Pretty straightforward. Okay. In exercise 5, we have a sample of 3 dozen jumbo eggs. How many eggs is that? Okay. They grab 36 eggs and they average all of their weights. The average weight of those eggs is 69.7. And the sample standard deviation is 0.53. I crossed that out and gave you the number because there's something that I've taken out of all this. 0.53. So then in B, well, don't even worry about A because I already changed and gave you the standard deviation of 0.53. What would the margin of error be for the population mean weight? So that's 69.7 plus or minus 2 times the standard deviation, which is 69.7 plus or minus 2 times 0.53. So 69.7 plus 2 times 0.53 could be 7.76. Okay. So actually, let me go back to this, but I want to be careful one thing. The actual margin of error is this number, 1.06. But usually they don't ask you that without asking you for the appropriate window. So the margin of error, MOE, is 1.06, and then the appropriate window would be anywhere from 68.64 to 70.76. So C, and this is common for this type of question, is an application. So jumbo eggs are considered to be eggs with weights at or above 70 grams. Is this within the margin of error for this sample? Is 70 grams within the margin of error? Yes. If you just look at the data, you would say, nope, these eggs are not good. These eggs are not acceptable. But there is this margin of error that gives us a little bit of a window. So just because you pick up like an M&M package and it says that there's 6 ounces in there, there's an acceptable margin of error. It might be anywhere between 5.9 ounces and 6.1 ounces. And then it's not going to be considered false advertising. Okay, does that make sense? So yes would be the answer. And your explanation could be, the window range for acceptable jumbo eggs is anywhere between the two numbers we got, 68.64 and 70.76. And now we're going to do an activity with that because that sentence is wrong. Who thinks they have a feel for where I went wrong in wording this? This isn't our window for acceptable jumbo eggs. Because if the jumbo egg cutoff is at 70, the window for what would truly be acceptable would be 70 plus or minus something. Okay? What I actually have here is, even though my mean weight was 69.7, the how do I want to phrase this? The range of possibilities for those types of eggs could be as high as 70.76 or as low as 68.64. So given that this surpasses the 70 cutoff, they could be in that jumbo egg categorization. So how do I want to change this? The window range for acceptable jumbo eggs. It's more about the sample of jumbo eggs could come from a population whose mean is anywhere between those numbers. Nathan. Absolutely. And honestly, you're probably better off leaving it just like to the data rather than interpreting it, which is what my sentence is trying to do right now so that you guys can make sense of this. But you probably are better off just keeping it when you do right, when you can. Sometimes they will ask you to interpret, though, and that's what they're getting at. But keeping it generic like that is safer on a test. Just saying that yes, because 70 falls within those two numbers is what he's saying. Just keeping it to the data. But the interpretation is what I'm getting at so that you can help wrap your head around this. Is kind of what we just wrote right there. That even though our sample is lower than the cutoff, the margin of error makes it possible that this sample came from a population that truly is in the jumbo range. And then on the last one, just a survey of 50 people in their lower 20s was determined to get their mean. Their mean is 495. And the standard deviation was 6.79. So plus or minus 2 times 6.79. So the average that was just the sample. The average was for the whole population is 472. When you add and subtract your 2 times 6.79 here, you just essentially want to see if 472 is within that range. So again, Nathan, Henry, to your point, do the results of the survey imply an increase? You could say no, because it falls within 2 standard deviations of the range. So it might have been a coincidence. If it was outside 2 standard deviations, you would say yes. You know, for whatever reason, these people are making less money than, or more money, I guess, than is typical.